Hello class, today we're doing the Chapter 2 final review. So this chapter is all about fractions, decimals, and percents. So let's talk about fractions. A fraction is simply division. It is a numerator divided by the denominator. We see that sign right there, and we've talked about that before. That division sign we see here is simply the numerator divided by the denominator. Those dots are placeholders for the numerator and for the denominator. Fractions can also be integers. For example, 2 is a fraction. It's just 2 over 1. A million is a fraction. It's just a million over 1. Smiley face is a fraction. It's just smiley face over 1. Anything can be a fraction. So, to simplify a fraction, you have to divide the top and the bottom by their greatest common factor. So, remember our rule? What you do to the top, you do to the bottom. So, for example, if I had this one here, I have 9 21sts, and I just did this one straight out, 9 21sts. So I found the factors of them. I found the factors, and I found, okay, they both have a 3. Now, there's the cheat method, where first, there's the normal method where you just divide each by 3. 9 divided by 3, 3. 21 divided by 3, 7. Or you can match the pairings. You can match the factor pairings. I write them like this for a specific reason. Because when we divide by 3, the new answer is 3. When we divide by 3 here, the new answer is 7. Look, 3, 7. Woo! So that's why I always write them out, matching your factors instead of writing up and down and stuff, because it helps to keep it organized and you can see what it's gonna be. So, to simplify a fraction, you simply divide the top and the bottom by their greatest common factor. That is the only way that you can simplify a fraction and still get a fraction. So here I have some numbers on the screen, and I want you to tell me in the chat if they are decimals. So first, is this a decimal? 1 75/100ths. Is that a decimal? Yes, we're getting an overwhelming amount of yes. Excellent. That is a decimal. What about 3 8/10ths? 3 8/10ths, is that a decimal? Awesome. Yes, we're getting a lot of overwhelming responses. What about 2? Is 2 a decimal? Oh, we're going some back and forth here. We're seeing this. We're seeing no and we're seeing yes. Someone who says no. Let's see. So what we're seeing here is a lot of people say there's no decimal. We don't see that dot there. We see no decimal. We see Izzy say there's always a number behind it, stuff like that. Here's the thing. 2 is a decimal. It is 2.0. Anything, again, can be a decimal. It will just have infinite zeros after it. And anything can have infinite zeros after it. So just because if I had put a 2.0, wouldn't you guys have said that was a decimal? Yeah, because now you see the decimal. So there's that invisible dot. We also know that's a decimal. Let's look. If I had that 0 5/10ths, does that change the amount of the number? Does that change the value? No. Does this change the value of my number? No. Does this change the value of my number? No. I could have infinite zeros at the right-hand side, the furthest to the right. I could also have infinite zeros on the left-hand side, furthest to the left. It would just be dumb to do, but it's dumb to do to the right as well. However, it doesn't change the value of our numbers at all. So, anything, again, can be a decimal, right? The only things that wouldn't necessarily be a decimal outright would be a fraction. We would have to do something to our fraction to make it into a decimal. But in the end, we could make it into a decimal. So, any number is a decimal. For example, 3 6/10ths, 0 25/100ths, and 2 0 anythings. If a number does not have a decimal, it is at the right-hand end. So all the way at the end, just like that 2 goes to 2 0 0 zeros. So then, we also see that there can be infinite zeros after the farthest right number. 2.3, 2 and 3/10 is the same as 2.30, which is the same as 2.300000, and it's all the same. So decimals all look like that. What about percents? What do we know about? So percents, per means one, each, out of. If I said I have one desk per student, that means each student gets their own desk. One student, one desk. Cent means 100. In different languages, cent means 100. For example, in Spanish, I believe. In English, after 100 years, it's called a century. There are 100 cents in $1. So when you see that word cent, C-E-N-T, think of 100. Think of that 100. So percent means out of 100. So if I had 2%, what that means is it is 2 out of 100. And that can also be written as 2 out of 100 because it's 2 parts out of that 100, right? It's 2 parts. The part is 2, then the whole is that 100. So what we're going to learn to do is how to go back and forth between each of them. So between a fraction and a decimal, first, to go from a fraction to a decimal, let's say I have my fraction 1/2. You might already have this memorized, what our fraction is, or what our decimal would be. So Izzy says she already knows it's 0.5. Emmett knows it's 0.5. Great, so we already know that. But you might not know some automatically. For example, 2/5. It's already simplified as it can be. There are no greatest common factors. 2 is prime and 5 is also prime. But let's think about that. All you have to do to go from a fraction to a decimal is long divide. Which number are we dividing again? If we looked back here, we are dividing the numerator by the denominator. We are dividing top by bottom. So inside of our house is our 2, and outside of our house is 5. So now we're going to find the quotient of that. Now, how many times does 5 go into 2? If I have 2 pairs of pants and I have 5 people, how many times does it go in? It goes in 0 into 2. So then we have to put our decimal, just like we're doing before. It goes in that 0 times. So we have a 0 point and a 0.0. I like this because it's kind of that reverse, 0 point, 0.0. But now, how many times does 5 go in to 20? And this is what I see a couple of you guys wrote already because you're speeding ahead, speedy speedster. It goes in 4 times, and that is exactly 20. We subtract, we get 0. When you get 0 at the bottom, you're done. There's no remainder. So 2/5 as a fraction, or 2/5 as a decimal is 0 and 4/10. There we go. Now, if we had a decimal to make it into a fraction, let's do the same example. I have that 0 and 4/10. To make it into a fraction, I care about the place value of the number to the farthest right. I care about the place value of the number to the farthest right. So what place value is that? Who can type it in the chat? What place value is that? Perfect. We see you guys have answered tenths. So this is the tenths column. And all we do is we put this number over its place value. So our fraction becomes 4/10. But wait a second. How is that possible? We just saw that 0 and 4/10 is equal to 2/5, and now I'm getting a completely different fraction. Oh my god, we must have done something wrong. What happened? What did we do wrong? Izzy answered, it simplifies to 2/5. The GCF of 4 and 10 is 2. Exactly. Fernando said you multiplied by 2. Exactly. Our GCF is 2. Now, I don't necessarily always know the GCF off the top of my head. Sometimes it's big numbers and I don't know it. But I look at this one. 4 is even. 10 is even. So I'm just going to divide by 2. If they're both even, you can divide by 2 until you simply can't divide by 2 anymore. It's easy that way. So I divide them both by 2. They're both even. And I get 2/5. Magic! So, look at that. We get all of those same answers. So what if I had a different example? Again, if I wanted to do the decimal, let's just say here I'm doing a decimal to a fraction. I've got my decimal 3 and 3.17, or 3, and if you said that, 3 and 1700ths. We care about the place value, but which place value do we care about? This place value is our ones. This one, as we saw before, is our tenths. If we can guess accurately, this one is our hundredths. Which place value do I care about? The last one I cared about the tenths, so I'm going to make it a tenth, right? So which place value do I care about? As Izzy said, we care about that last place value, the furthest to the right. So now, here, I'm going to write it like this, right? 317 over 100, right? Is that correct? What do we think? The answer is yes. So we have our furthest place value and we put whatever is to the left over it, just like that, everything. And then we simplify. This is essentially 300 plus 17 over 100. So let's simplify it. What does 300 over 100 simplify to? If I have 300 100ths, one thing I can do is I can just cross off the matching zeros right there. And I'm left with 3 over 1. And as Izzy wrote, that's 3. Remember we talked about that? Anything over 1? So then I get 3. Then I still have that 17 over 100. Can I simplify that anymore? Can I get any smaller than 3 and 17 hundredths? No, I can't, because 17 is prime. So there's no GCF to simplify. 17 is prime. The only way it will work is if our denominator is divisible by that numerator's prime number. So for example, 51 is divisible by 17. So if our denominator happened to be 51, then we could simplify it and then we would get 1 whatever. But our GCF for 17 is, so for our factors of 17, we already know it's 1 and 17. Dividing by 1 does nothing for us. So we would have to divide by 17 in order to get an answer that actually mattered. So because 100 is not divisible by 17, we know that is the answer. So that is how we go from a decimal to a fraction. What about this? I want to go from a decimal to a percent. So here's my decimal. I've got 0.4 or 4/10. So I care about this. How do I make it into a percent sign? How do I make this into a percent? So Madison, what do we do?
Move the decimal point 2 times to the right.
Do you know why we do that?
Because when you do that, it ends at 100th.
Yes, that's a great idea. It doesn't necessarily end at the 100th, but she is on the complete right track. That is exactly what we do. We move it over. Nathan says, don't you have to move the decimal? We move it to the right. Here's how I remember it. Percent sign is towards the right. 100%. That's towards the right. 100%. We're going to go over this on the next slide because this is something that's really important. So we move it over. Boop, boop. 2 times to the right. So now my decimal is there. And I end up with 40%. This would also make sense. 0.4 is equal, the same thing is here. Same thing, 0.40. This is 40 out of 100. 40 out of that 100, which is 40%. So we see that right there. So we move it over. I remember to move it over twice because 1 dot, 2 dots. You see that on the percent sign right there? There's 2 little circly circles in that percent sign. So that's how I remember we move it over twice. We do the same thing from percent to decimal, just reversed. If I had, let's say I had 5%, we just do the opposite. Our decimal is right here. So we want to move it away from the percent sign twice, like the same amount of dots. I want to get rid of those dots. So I move it 1, 2. And I get my decimal to be 0 and 5 hundredths, right? 0 and 5 hundredths. So I see that. And it's making a lot of sense so far, hopefully, to you guys. Now, when we're doing this, there are many ways to find decimals. In fact, I want you guys to try these. So as a decimal, I want you to find the percent of 3.6, of 0.02. I want you to find the percents of those two. I added that other one, 0.0003, or 0 and 3 10,000ths, I think, would be that place value. But we're doing it to percent, so we don't even need to necessarily think about place value in the beginning. We just follow those same steps. So we got Izzy, Hannah, and Madison answered this. We move our decimal over 1, 2. It ends there. So we get 360%. What about this one? 0.02, or 0 and 2 hundredths. Excellent. Hannah, Izzy, Madison, Emmett, we got that. We move it over 1, 2. It becomes 2%. What about this one at the bottom? 0.0003. What does that become as a percent? Ooh, this is interesting. This is a weird one, right? So the answers so far that I have gotten are I got 0.03, I got 30, I got 3, I got 0.3. So these are the ones that I've gotten so far. Let's check which one is right, because one of these is correct. We follow those same steps. Perfect. So one of these is correct. We just followed those same steps as before. I move my decimal over 1 time, 2 times. So which one is our answer? It can't be 30 because we don't have that 30. It can't be 3. It can't be 0.3. Our answer is 0.03, or 3/100ths of a percent. I know. Weird, right? It's super possible to have percents over 100, less than 100, and even less than 1. All of those are possible. What about this one? So we did that first example earlier. We did that 5% became 0.05. What about 250? I'm going to put the percent sign just so we don't get confused. Percent and 0.008%. So I want you guys to write those as decimals. I want you to write those as our decimals. So let's see the answers I got. So far, as I scroll, every single person got the first one correct. We got all the way over here. We move our decimals. We get 2 and 5/10, 2.5. Now, I'm seeing some different answers for some of these, but a lot of you have gotten this one correct. Are you ready? We move our decimal over. 1, 2. We now put another 0 there. So I get 0 point, and I get 1, 2, 3, 4. So 1, 2, 3, 4, and then our 8. Look at that. I know. These crazy numbers, right? We see these. It still is accurate, because you can have percents less than 1%, more than 100%, all of that. We can see that. So, to go from a decimal to a fraction, we move our decimal 2 times to the right, towards that percent sign. To go from I meant percent. To go from percent to decimal, we move our decimal 2 times to the left, away from our percent sign. So to make it a percent, towards the percent sign twice for those 2 dots. Dot, dot. To get it away, we move it twice to the left. Dot, dot, twice. Now, from a percent to a fraction or from a fraction to a percent, right? Percent to a fraction. First, we make it into a decimal. So if I had 2%, I make it into my decimal. Or, that's one way to do it. Or, so it would be 1, 2, I would get 0.02, which that's going to be over 100 because that's right there, right? Actually doing it super duper wrong. If it was a fraction, it's going to be 2 over 100. 2%, yeah, it's going to be 2 over 100 as our fraction, which can simplify. They're both even to 1 over 50. And if I wanted to do that, so that's how we did it. If I wanted to make a fraction into a percent, this one's the one that's a little bit more tricky. So if I wanted to make 2/5 into a percent, I could either use a function table for this one, a ratio table where I fill it out and I want to get to that 100 because percent means out of 100. In this case, 5 works out evenly. I've got 2/5 to get from 5 to 100. We don't know what x is. We always want to point to our x. We're pirates. It's times 20 times 20. So our x would equal 40. So it would be 40%. But that only works if they share necessarily greatest common factors or something they can be divisible by. What if I had something like 2/7? Can I multiply 7 to get 100 by anything? No. It's not worth it to do it that way. In this case, the way that we would want to get it is we would want to turn it into a decimal first. So we do the long division, 2 divided by 7. We find out our decimal. It's going to be very long. I don't want to deal with it. Let's see what it is on the calculator. It is 2 divided by 7 gives me, and then it starts repeating, 0.0285714, and then it starts repeating at 2. Oh, that's 0.2 divided by 7. Ignore that. It's point. Let's put the... I messed up there. I accidentally hit that. So it's there. There we go. Makes a little bit more sense. So we get there. And if we noticed, our denominator is 7, and these repeat after 6. So that's pretty cool. Our denominator is 7, it repeats after 6. That is always what happens when our denominator is 7. After 6 numbers, it starts to repeat. That doesn't work for all of them. After 5, it doesn't repeat 4 times and stuff like that. But after these weird kind of prime numbers. Then we turn our decimal into a percent. We move our decimal towards the percent. Boop, boop. I get that 28 point, and I'm just going to round it, 6%. It's super annoying, but that's the way we got to do it because it doesn't go to 100 evenly. Now, you can use function tables with almost anything. If they are even numbers, use our function table. It'll immediately work. If they are not, if we've got prime numbers, you got to do this long division thing. That's how we do it. To find a percent of a number, all you have to do is multiply it in decimal form by said number. So if I wanted to find, for example, let's see, find this. One of the options is to do our decimal trick. We move it over, 1, 2, we get 0.1, and then we multiply it times our number. 0.1 times 2 gives me 0.2. That makes sense. 10% is less than 100, so of course we're going to get a number less than our original, right? Because that's the percent. Same thing here. We would move our decimal over, so we would get this, I just want to write it down, is 0.2. Same case, we move it over twice. We do our multiplication, 0.003 times 9 is literally, it just gives us 0.027. Again, makes sense because it's going to be much smaller. 250% of 5. We're over 100%. So we're probably going to get a number, not probably, we are going to get a number bigger than our original number. We move our decimal, 1, 2. We now multiply 2.5 times 5, and we get 12 and 5/10. That's all it takes. But there is one more way, and this is the way that I like the most. And this is the way that you should remember. Ready? Is over of equals percent over 100. This is something you need to remember. This is something great. Is over of equals percent over 100. So for example, let's look back. 250% of 5. So here, I've got my percent. 250% over 100%. Then, is over of. I don't have an is here. I'm trying to find what is that. What is? So I don't know, but I know that my answer here is 5. And I just follow those same steps. I follow those same steps. We want to go towards the x. Towards the x, I divide by 20. So again, let's do this. So I'm correct. We do this. I divide 100 to 5. We divide by 20. So I do the same here. 250 divided by 20, if you do that with your calculator, gets you 12 and 5/10. Same exact thing. Is over of is equal to percent over 100. So even if I had something like this, let's say I had 210 is 80% of what number? I do my is over of. First, let's do this. 210 is. 210 is what number? Because it says of what number? We don't know that. X is equal to, we got our 80% over 100. All I do is I want to go towards the x. It doesn't necessarily always evenly work out, so we would do our function tables. In this case, I also suggest going the decimal route because it might be easier, but we could do this. Both of them have I believe a GCF of, let's say, 10. That works. So if we did our function table, we would set it up like this. We would have 80 over 100. Let's divide them both by 10. 8 over 10. And then to get to, actually, wait, I want to divide it by 8. That's not working out nicely. Let's divide it by maybe 5. So I think their greatest common factor ends up being 16 if I found out the factors. In this case, I divided by 5. So I do the same here. Divide by 5. And I get this one to be 20. Then I want to get this equal to that 210. How do I go from 16 to 210? 210 divided by 16. It's not working out. I don't know what my problem is. Do it in the decimal form for this one. It's just easier if we did it in this way, the decimal form. But if you can, try the is over of if it evenly works out. If it doesn't evenly work out, don't do it and do the decimal. See how I'm getting all of that? It's all not working out. But whatever. It shouldn't. So overall, that is what we need to do. That is all it takes. I also remember a fraction. This is my last thing I remember. A fraction is over 100. Let's look at this. That 2%, we know it's over 100. It's 2 over 100. The reason being is we get 1, and then we get 100. Do we see those orange dots? We got that. If I made it nice and thick, we got 100. So that's how I remember that a percent goes over 100. To get rid of that 100 mark, to make that part go away, I just put it over that matching 100. And then, boop, it's gone. That's really all there is to this lesson. You need to know how to go back and forth between our fractions, decimals, and percents. You should know how to go back and forth between all of them. So there we go.